Okay, hello everyone. So we're going to have a look at some more of these and see how we get on. We're going to look at the really hard ones now. So, just bear with us. The rules are very simple. Sine rule is sine rule. It's just a matter really of just kind of accessing it in whichever way, shape, or form it determines. So listen, let's just throw a few of these at us. You'll enjoy them, I think. Okay, one for you. Okay. So hope you can see this. This is a nice little triangle I've drawn. Now listen, I'm only drawing these like this because I wanted to make it all nice and kind of gooey for you. So we have one side of 5.4 centimeters. We have this side of 32. We have a tree and a tree. Okay, and these corners are called A, B, and we have two possibilities, C1 and C2. And the question is, the diagram shows two possible triangles with where one side is 5.4 and one angle is 32. So there is actually two possibilities you could make, and you can use a compass to show this. I'll just show you here. Okay. So what they're saying is that this, if this line and this angle subtended from that line, there's two possibilities where you could get a tree for the second line. Okay, one of them is there, one of them is there. It's as simple as that. Okay, so if that makes sense, yeah, watch. There's two possibilities. If you subtended a tree and then drew a line, there's two possibilities where it could hit. That's what really they're sending it. Okay, so we have to try and find the two possible values of the angle. So what we want is this angle, C1, or this angle, C1. So you want to find both those possibilities. Okay, so let's think about it for a second, because I think with a lot of these questions, if you just your own time for a second, you'll figure out what you have to do. Okay, so here, if we want this angle, I have a side opposite it. If I have this side, I have the angle up. Let's see what that generates. Let's see what the possibility for that is. 5.4 over the sine of C1 is equal to 3 over the sine of 32. So we can get C1 here fairly easily. Okay. So we're going to get a sine inverse of, what is it? 5.4 times the sine of 32 over 3. So sine inverse of 5.4 times the sine, 32 degrees over 3, close the bracket, 72 and a half. Let's go with 72 and a half. That's one possibility for it. Okay. Now, if you look at this carefully, that does not look like 72 and a half, does it? In fact, that looks like it's an obtuse angle. That looks like 72 and a half. So if one of them is 72 and a half, then the other one must be in the second quadrant, because it's between 90 and 180. So if I take 180 from 72 and a half, I'm getting 107 and a half, let's call it. So the other possibility is 107 and a half. So one of them is 107 and a half, probably this one, because it looks obtuse. This one looks acute, so it looks like 72 and a half. But there is two possibilities. So there you go. There's a nice little tricksy one just to get you started. I think it's a lovely one, actually, that one. Okay, all right. So let's try another one. I love these questions because you can just have fun with them. Okay, ooh, I like this one. So we have a tower. Not great at towers. tower and we have the ground. And then we have two, I don't know, two angles coming down. I'll draw these in different colors just to help us out. One of them is 32 degrees. So 32 degrees. I don't know what these things are. They're just anglers, and this one's 25 degrees. And the distance between these two is 20 meters. Now, find the height of the radio tower. Okay. Simple as that. So if we had ignored this, if we just had a right angle triangle, I have no information. I don't have a hypotenuse, I don't have an underside. Okay. What am I left with? That's what we're really saying. Okay. So what you have to do is you have to think to yourself, well, can I fill in any more information first of all? And I can straight away see that there is more information I can put in. I can definitely put in this angle here if I wanted to. So this angle here is 32 minus 180. Okay. Why is it? Because it's a straight line. 148. Now, does that give me options? Well, let's see what it does. Okay. It means that I can find the third side up, or third angle up here, which would give me one pair of opposite and allow me to get a second pair of opposite. Okay. And if I can get that pair of opposite, or this pair of opposite more importantly, then once I have this becomes the hypotenuse, and I have an angle, and I can find. So that's one way into this kind of system. See, what you're trying to do is build your way into the problem so that you can feel your way through it, and it doesn't become like all-encompassing, tough little question. It just becomes what it is, like, you know. So let's find this little baby up here. 148 and 25 is 173, is it? Yeah, 173 minus 180, that's 7 degrees up here. So now I have the three sides. Okay, so how would I find this one here? Well, it's going to be 7 degrees and the 20, and then the 25 and the unknown. So let's call this one x, I don't know. So x over the sine of 25 degrees would be equal to 20 meters over the sine 7 degrees. That's going to give me x. And once I have x, then I can just do a simple sine formula to find the height. So what are we looking for here? We're looking for x is going to be 20 sine 25 over sine 7. It's going to be a big enough number. Okay, 20 by the sine of 25 divided by the sine 7. 69.36. So now I have the hypotenuse. And of course, once you know the hypotenuse, things start to become a little bit easier, don't they? Because now the sine of 32 is the height of the building over the hypotenuse. So now the sine of 32 degrees is equal to the height of the building over 69.36. That's just a simple cross. So the height of the building is going to be that answer multiplied by the sine 32, which is 36.75 meters tall. Okay, so don't know if that's a big building or not. Okay, don't know if that's a big building. It's 36 meters. I don't know what that's. It's about 10 stories, 12 stories high. Okay, so there's another example of how to do it. So you can see this stuff has actually a real life application. Now, when you're saying no, it doesn't, but it does have a real life application. We'll try another one. Okay, let's try another one. Oh, I love these ones. Okay. I used to do these all the time when we were doing applied maths. I used to love these type of questions because they really do test your kind of ingenuity. Okay, so here we have, I'm going to get some, this is the river. Okay, shading it in here. I'm getting real pro at this. And we have some help on this river. We have 3 angles. It's 800 meters between B and C. and we have a couple of angles here, 50 and 30 degrees. And the question is, Barry and Colin swim across the a parallel-sided river to a point A. Barry starts at B and Colin starts at C. Calculate the distance each of them have to swim. So I want to know how long it takes Barry, and then how long it takes, or sorry, not how long, how far it takes. So I need these two sides, basically. In other words, find the rest of the triangle. So let's see what we have. Okay, well, we have a lot of information here. First of all, I have one side of the triangle. If I knew the other side, that would help. So how can I find the other side? Sorry, how do I find the opposite angle? Well, 50 plus 30 is 80. This is a straight line, so that must make this 100. Okay, now that helps me a little bit, but it'd help me more if I knew what that was and that was. Now, if you remember back to your junior cert, if these are parallel lines, then any line joining it, you can apply what's called alternate angles. So if that is 50, that makes that 50. And if that is 30, that makes that 30. Okay? So the question now becomes, can we figure this out? Okay. Let's have a look. I think we can. So let's go for AB first. Okay, so 800 over the sine of 100 is equal to AB over the sine of 30. So that makes AB equal to the length of AB equal to 800 by the sine of 30 divided by the sine of 100. 400, that can't be right. 406 meters. Jesus Christ, he's some swimmer. Okay. Now let's check the other lad. We're dealing with some swimmers here. It's kind of the same, but it's a reversal, really. It's still going to be 800 over the sine of 100 is equal to AC over the sine of 50. It's going to be a bit shorter for this lad, I think. Okay. 800 by the sine 50 divided by the sine of 100. 622. Jesus, mother of God. So AC is equal to 622 meters. Now, to me, that seems like an awful distance to be swimming. To be mad, those lads. Absolutely mad to be swimming that distance. But anyway, listen, who are we to judge these young men who decides to swim this far? It's crazy swimming. Now, sorry, I'm going off on a tangent here, but the real cool thing is, let's say the river is flowing this way. Okay, so when we used to apply maths, we'd have to predict the speed at which they'd get across based on how far they'd move and all that, and really cool stuff. But anyway, Sine, that is it. Okay, so listen, there's some little harder versions, so hope you enjoy them, and listen, I will see you in the next video.